Hey guys, welcome back to part 2 of the introduction to derivatives. So we're going to start with some practice problems. So we're going to find the derivative of f of x is equal to x squared using the limit definition. So we have this formula over here. So we have the limit as change in x approaches 0 of x plus change in x squared minus x squared over change in x. So this part over here, it's just f of x plus change in x, because f of x is x squared, but you were to plug in some value into there, which is just x plus change in x. So once you expand that, I'm sorry for the bad handwriting, you get x plus 2x change in x plus change in x squared minus x squared cancels out, all divided by change in x. So now you have the limit as change in x approaches 0 of 2x change in x plus change in x squared over change in x. So you can cancel this term out, but you're still left with a change in x. So you have a limit as change in x approaches 0 of 2x plus change in x. So when you evaluate that, you're left with 2x. So that's the derivative using the limit definition. Okay, this is the work that I did, but instead of changing x, you use h. And this is what I got. Okay, so now we're going to find the derivative of square root of x at f prime of 3 using the alternate definition. So we have f prime of 3 equal to the limit as x approaches 3. So we can rewrite f of x as x to the power 1/2. So we have x to the power 1/2 minus f of a. So we have the square root of 3 divided by x minus 3. So as you can see, there's a radical and we want to simplify it. So we're going to multiply by the conjugate. So we have plus square root of 3 over plus square root of 3. So now we have the limit as x approaches 3 of x minus 3 over x minus 3 times x to the power of 1/2 plus square root of 3, sorry. These factors cancel out, so now you're left with limit as x approaches 3, 1 over x1, to the power of 1/2 plus square root of 3. So now let's plug in 3. So now we have 1 over square root of 3 plus square root of 3. And that's equal to 1 over 2 square root of 3. If you were to rationalize the denominator, you have square root of 3 over 2, and that would be your final answer. This is the work for it. So now we're going to find the equation of the tangent line to f of x. We're going to find the derivative. Okay, so now we're going to find f prime of 3 for f of x is equal to x cubed. So we're going to use the alternate definition. So we're going to say limit as x approaches 3. We have x cubed. Okay, that's our f of x minus, let's plug in 3 into here. So we have 27 over x minus 3. But if you can recognize, you can factor this out. So you have limit x approaches 3, x minus 3, x squared plus 3x plus 9 over x minus 3. These get canceled out, so now we have the limit as x approaches 3 of x squared plus 3x plus 9. So now when you plug in 3, you have 9 plus 9 plus 9, and that's equal to 27. So let me erase everything. So this is equal to 27, but now we're going to look for the tangent line at x equals 3. So we're going to plug in y minus f of 3 is equal to 27 x minus 3. So f of 3 is just 3 cubed, or 27. So we can say y minus 27 is equal to 27x minus 81. So now we have y is equal to 27x minus 54 as our equation for the tangent line. Okay, so we are being asked to find the derivative of f of x at 4 for when f of x is equal to 2 over x. So let's use the alternate definition, f prime of 4, that's equal to the limit as x approaches 4 of 2 over x minus 2 over 4, or just 1/2 over x minus 4. So what we can do is we can multiply the denominator and numerator by 2x. So now we have that the limit as x approaches 4 of 4 minus x. Let's see, we have x minus 4 times 2x, but we can factor out a negative here. So now we have negative 4 plus x. As you can see here, this is the same thing on the numerator as the denominator, so we can cancel this out or factor it out. So now we have the limit as x approaches 4 of negative 1 over 2x. So we can plug in 4 into here, so we have negative 1 over 8 as our derivative at this point. So we have that. So now we're trying to find the tangent line equation. So we have that y minus f of a. So we have y minus 2 over 4, which is just 1/2, is equal to negative 1 over 8 x minus, let's see, 4. So now we have y is equal to negative 1 over 8 x plus 1/2 plus 1/2, which is equal to y is equal to 1 over 8x plus 1, and that is our final answer, negative 1 over 8x. Make sure to keep your signs consistent. Very sorry about that. So now we're going to find the perpendicular line to f of x is equal to 2 over x at x equals 4. So the points here will stay the same, but the only thing that will change is the slope. So the perpendicular slope will be negative 1 over f prime of a, and that's equal to negative 1 over negative 1 over 8. The negatives cancel out and the 8 goes on top, so you get that the new slope is equal to 8. So let's see, that's f of a, or f of 4, that's negative 1/2. So we have 8 times x minus 4. So now we have y is equal to 8x minus 32 plus 1/2. And we can rewrite this as y is equal to 8x, so 32, that's negative 64 over 2, plus 1/2, that would be 63. So we have y is equal to 8x minus 63 over 2. And that is our final answer for the perpendicular line at x equals 4. Thank you for watching this video, and stay tuned for more.